Let me do a simple tutorial to apply a Gauss Divergence Theorem. Example. Apply Gauss Divergence Theorem if function f equals to 2xi minus 2yj plus z square minus 1 into k with the cylindrical volume located in xy plane from z equals to 0 to z equals to 1. Solution. The formula of the Gauss Divergence Theorem is that surface integral equals to the volume integral. Look at here. I use arrowhead on the top of n for the unit vector, but sometimes you may use cap, n cap. Whether you use n cap or whether you use arrowhead on the top of n, it is a unit vector. So this left hand side equals to the right hand side. Let me draw xyz plane and let me put the cylindrical volume. This is my cylindrical volume which lies in xy plane, because the question asks that cylindrical volume lies in xy plane where z equals to 0 to z equals to 1. So let me apply a Gauss Divergence Theorem where I'm gonna find the right hand side. Just ignore the left hand side. I don't need to calculate it. I will only calculate the right hand side, which is the volume integration. So the first thing that I'm gonna do here is to find the divergence, where divergence equals to the dot product of del and f. Del is I partial or partial x plus j partial or partial y plus k partial or partial z. And dot product of f is here, which is 2xi minus 2yj plus z square minus 1 into k. When I take the dot product between these 2 points, I times I equals to 1. Similarly here, j times j equals to 1, k times k equals to 1. So I finally left with partial of 2x or partial x plus partial of minus 2y or partial y plus partial of z square minus 1 or partial z. Let me do partial derivatives, which equals to 2 minus 2 plus 2z, which equals to 2z. This is the final value for the divergence. Let me put it here. So my new equation will be 2z dx dy dz. 2z is the value for the divergence. But how I put the limits here, did you notice that? Look to the equation. The equation says that cylindrical volume lies in xy plane. So the bottom of this cylinder lies in xy plane. When you look to the bottom of the cylinder from the downside, it exactly looks like a circle. So I will simply consider it as a circle, where the coordinates on these circles are minus 2, 0 to plus 2, 0. Where the coordinates for the y ranges from minus 4 minus x squared under the root to plus 4 minus x squared under the root. The limits along x-axis ranges from x equals to minus 2 to x equals to plus 2. But for the y limits, I got the y limits from this equation, which is the cylindrical volume equation, x squared plus y squared equals to 4. Can I write it x squared plus y squared equals to 2 to the 2? 2 is the radius of this circle. So from this equation, I got the limits for y. Just rearrange this equation, which equals to y equals to 4 minus x squared under the root. That's how I got the limits for y. For z, it ranges from z equals to 0 to z equals to 1. Let me first integrate it with respect to z to have 2z squared over 2. Expand the limits. Finally, I have 1 dx dy. This equation is a perfect circle because I left with the dx and dy, since the bottom lies in xy plane, which is exactly a circle. Therefore, can I write simply pi r square, which is the equation of a circle. But look, you must keep in mind that at this stage, this equation equals to the circle. In other case, you must calculate for all the 3 integration, where r is the radius, which is 2. This is my final value when I apply the Gauss Divergence Theorem, which is the value for the right hand side.